Okay, so welcome to this, and I would request you to please mute your mics.
Everyone mute your mics or mute all. And mute all, sir. And
Okay,
your mic.
okay, good.
Okay.
So we will start this three series workshop on numerical methods, and in this workshop, I will be using the environment Python. So Python is a high-level programming language, and in this programming language, you have a lot of tools available, such as NumPy, SciPy. So these tools make life easy, unlike C, where you have to encode a lot of things to get your job done. Of course, there are some libraries available for C as well. For plotting, there is something called as matplotlib. So these are the modules available in Python which we will be using, and you will see very quickly that Python is a very convenient framework in which you can get a lot of work done with very little lines of code. So in case you do not have Python, don't worry, it's free software, it's open source software, and it can be installed via Anaconda. You can go on the internet, you can search for Anaconda. Once you download Anaconda, Anaconda is basically a package manager for Python, and you can install various packages that you need from inside Anaconda. Okay. It also exists for Windows platform. So there is an environment called as Spyder. Spyder is an environment in which we can develop Python scripts, and we can make a lot of developments within a convenient framework where the plotting, where the scripts, where the command window, everything is in a convenient frame. And this was made keeping in mind the user interface of MATLAB. So people who are comfortable with MATLAB will also find themselves very comfortable in Spyder. So let us proceed with the first task. Let us first see a very simple example. Rather, before going into the problems, let us see the various kinds of objects that we will encounter throughout our study. So the first object that we will encounter is printing something. Okay. So let me change the screen. So now you should be able to see my Spyder setup, right? Are you able to see the new window?
Yeah, sir. I am
Okay.
able to see.
So let me just tell you a bit about Spyder. This particular zone is called as the editor. This particular zone is where you can look at the variables, you can look at help, you can look at the plots, and you can look at the files. And this is the console. In the console, you can run certain commands. Of course, if you, I mean, you can do the entire thing through a console as well. So let me define a variable. So a variable is simply defined as a equal to 2. And then you can look in the variable editor, variable explorer, that you have a variable called a. Its type is integer, its size is 1, and the value held by it is 2. Let me again define another variable called as b. Let me define b as 3. In the variable editor, a variable explorer, you will now see a variable b whose value is 3. So I can define c equals a plus b. Now if I want to show the value, of course I can look at the value in the variable explorer as well. However, I can print the value of c as this. So print c gives me 5. Okay. Now I can do simple operations such as a multiplied by b. So let me assign it to d. So d equals a multiplied by b. Then I can print the value of d as well. it comes out as 6. I can do a simple operation of division. So let me define E as A divided by B. However, you will see that it is not exactly what you will expect. So if I do this, print E, it gives you 0.6666. However, in general, if you do not load NumPy, I have already loaded all those libraries, it will give you 0, because an integer division is not does not yield a floating point number. So this number is called as a floating point number, while things such as 1, 2 and all these things are called as integers. So floating point numbers, so in order to actually obtain floating point numbers in a different environment, this environment is quite specialized for mathematics. So you should define E as 5, so 2.0 divided by 3.0, okay, rather than 2 divided by 3. Now you also have certain special operands such as the modulo operator. So what does a modulo operator do? Suppose I have two integers. Say the first is, let me define new integers. So let g be equal to 10 and let h be equal to 8. So I want to know the remainder that remains when I divide g by h. So you know that the remainder is going to be 2. So the function to do that is g percentage h. So let me put the variable in I. So I will be equal to g percentage h. So let me print I. So I is equal to 2. So this is how you find out remainders. And these functions are very useful if you are sort of manipulating indices of matrices when you are doing things such as finite volume methods and finite element methods. These things are very, very useful. Okay, let us proceed to NumPy, which is what we will discuss mostly. So in order to import the functions and the libraries available inside NumPy, we will do import NumPy as NP. So it tells Python that, okay, I want to import whatever is there inside NumPy as NP. So NP is just an alias. I can choose not to do that. I can simply do import NumPy. Then I can do directory. So in the directory, I can see all the variables that are existing. So there is a variable called as NumPy. Okay, but so suppose I want to call simple functions. So I have to always do NumPy dot linspace and things like this. But I don't always want to type NumPy dot something. So I can simply import it as an alias. So import NumPy as NP. So NP is an alias for the keyword NumPy. So NP contains a lot of functions. So NP contains all these functions that you see. It contains angle, append, apply along axis, arrange, arccos, okay, arccos h. So all the mathematical functions that we typically use are held inside the module NumPy, and to call those functions, suppose I want to find out the sign of a number, so I will say np.sign and say I want to find out sign of 0.5 in radians. So it gives me the answer. Okay. I cannot simply call sign because sign does not exist in the programming environment. Sign is embedded inside the module NumPy, and I have to call it in that particular way. This is just a property of this programming language. The most useful things for which NumPy is very famous are arrays. So what are arrays? So an array is something which holds numbers. So we will not discuss the distinction between an array, a list, and such objects in Python, but we will directly focus on the NumPy array because this is where all the mathematics and the vectorization of the code happens. So what is an array? So an array is something which holds numbers. So something like 1, 2, 3, 4. This is an array of integers. B equals 1.2, 3.4, 5.2, and so on. This is an array of floating point numbers. So these are arrays. Actually, in NumPy, it is usually defined as ND array. The object is an ND array. So ND array stands for n-dimensional array. So as you can imagine, it is not just true for vectors like this. So this you would identify as vectors. But you can also define n-dimensional arrays such as 1.1, 2.3, 4.6, 5.2, 6.1, and so on. You can define these kind of objects as well. So these are called as ND arrays. So let us see how to create ND arrays. So let me overwrite the variable a. So a equals np dot nd array, and say I want to initialize a 4 cross 4 array. So let us see what a contains. So a is this. So a was defined as an ND array. Sorry. I'm sorry. I forgot to reshare. It should be fine now.
Okay.
Yeah. So like I said, I can overwrite the previous value of a by writing a equals np dot nd array. So nd array is the name of the function which initializes an array and saves it to a, and the arguments passed into nd array are the size. Okay. Actually, there are several other arguments, and you can see those. Let me define b as another array. So self slash args kw args. But for now, you don't need to worry about all these things. Okay, let me again define b as this. So when you define such things, they get initialized with some garbage. So these are all just garbage values. You don't have to really wonder what these values are. Okay, there is nothing sacrosanct about these values, but you can initialize them to zeros also. So you can say b equals np dot zeros and then the shape. So then b will be a 4 cross 4 matrix where all the elements of b are set to 0. Okay, so let us see how to query certain things. So np dot shape of b, this will tell you the dimensions of b. It is 4 cross 4. Let me define c as np dot ones, 5 rows and 3 columns. So now c has 5 rows and 3 columns. So ones meaning it initializes all the members of that array as 1 and stores whatever the output is into C. I can equivalently define a randomized array. So everyone knows what a random number is. So I can say d equals np dot random dot, say I want to define a normal distribution. So what things do I have to pass to the normal distribution? So don't worry about all this for now. Just look at what I'm writing. So then I have to give the size of the array. So say I have defined it as a 10 cross 10 array. Or let me define it as a 10 cross 8 array. Let's see what D is. So D is a larger array now. But there are too many elements for me to conveniently look. So instead, let me just say np dot shape of D. So it is 10 rows and 8 columns. And what the function did, the function that we had called was np.random.normal. It sampled from what is called as a normal distribution. A normal distribution requires two arguments, the mean and the variance. So the mean I have put it to 0 and the variance I have put it to 1. And it populates the matrix D using samplings from the normal distribution, and the size of the array is 10 rows and 8 columns. Okay, so let me show you how to pick up values from this array. So let us say I want to know what the, okay, before going into how to pick indices, we must keep in mind that the indices for Python, they start with 0. Meaning the first element of D will be D 0 comma 0. In mathematics we write it as D 1 comma 1, but programming languages like C and Python, they have the indices starting from 0. In fact, MATLAB has the starting index as 1. So in MATLAB you would write D 1 comma 1. Okay, so D 0 comma 0 is the first and the cornermost element of the matrix D. So let's see what D 0 comma 0 was. Yes, it was indeed minus 1.151666055. Okay, it has provided me much more decimals that I want. So I can choose to print out a shorter form. So if I do just print 0 comma 0, I will get the same output. But if I do print format and then specify that I only want say 6 decimals, so I say 2.3f, 2.6f. So it will only print the first 6 digits after the decimal point. So what have we done? Let me just write down the general format of the format function. Format the variable that we want, so d comma 0 comma 0, and the specifier. So the specifier is defined as something dot something f, meaning 2.6f means it will have leading tabs of 2 and it will show 6 decimal points after 6 digits after the decimal point, and it will be a floating point number. I can write it as d. Let's see what happens. So for integer usually you use d, but because the number is a float we cannot print it. So let me try to print more decimals, so 3.10f. Okay, so this is the output, and of course you have to pass it to print. You have to pass whatever the output is. So the simple output from the format function is a string, so this is called as a string. Okay, but usually in any mathematics programming environment we don't want to work with string. That is why you have to do a print, and it will print the string. You can print this string to a file, you can sort of display it on the terminal and so on. We will see such things as and when we encounter them. So in this course we will not rigorously start off with all the tools that we need, but we will see how to use them as and when required. Okay, we shall not constrain ourselves to a lengthy tutorial and then see what's going on. Okay, so let me access some other element of D. Okay, so what do you think the last element of D will be? So let me again write down the size of D. So nd dot shape D. Oh, sorry, np dot shape D. So D has a size of 10 rows and 8 columns. So because the first index is 0, the last row will have index of 9. And because the first index of the column is also 0, the last index of the column will be 7. So D 9 comma 7 will be the last element, and it has to be in square brackets. So this is the last element of the matrix D. Let us see if it is really true. So
can I interrupt for
yes, yes, of course.
All participants after 5 minutes they will automatically deactivate because the limit is over 40 minutes. So all the participants will rejoin after some time with the same link. Okay. Thank you. Okay, sir. Okay, sir. Okay, thank you. Continue, sir.
Okay.
Continue.
Now suppose I create a new array, a equals np.nd array, and I just say 3. So let's see what E is. So E has 3 numbers, 3 random numbers. I mean, you don't have to really worry about what these numbers are, because when you initialize, it will initialize with some garbage. So let me redefine the values inside the array. So let's say E0 equals 4.2, say E1 equals 2.4, and E2 equals 3.0. Now let me type what E is. So I have successfully overwritten the values that was initialized by Python. Now suppose I want to add another number to the array E. Suppose I want to add 5 to this particular array. So how do I do that? So the way to do it is E equals np dot append E comma 5.0. Now let's see what E is. So I have successfully added 5 to this particular array. Okay. So this is how you can increase the size of the array. You can put in various sizes of the array. Now suppose I want to take only the second, third and fourth element of E and save it to D. I can do D equals E 1, 2. So 0, 1, 2, 3. So I have to do E 1 to 4. So let's see what D is. So what have we done? We have sliced. This is called as slicing of an array. So what slicing is, I have taken a piece of this array and put it in D. And how have I chosen the piece of the array? This particular syntax means you take the first element of E and you go all the way to the third element. Not the third element, but rather the fourth element, because 1 to 4 means 1. So array index 1 to array index 3. There's a bit of confusion as to why they did it like this, but 1 to 4 is, let me write down in comments, 1 to 4 actually means 1, 2, 3. It does not mean 1, 2, 3, 4. So what I have essentially done is E 1 to 3, it actually means, rather E 1 to 4, it actually means E element number 1, 2 and 3. And element number 1, 2 and 3 means this element, this is the element number 1, this element is element number 2, this element is element number 3. Because we recall that in Python the element numbering starts with 0. So this is element number 4, element number 0. Okay. So let me again write down what E is. Let us choose the first two elements and put it into F. So F equals E 0 to 2. So this will choose the 0th element, the index number 0 and index number 1 of E and put it into F. So let's see what F is. So as you see, F is equal to these two elements. So it's a very simple thing if you get used to it, and the only trick is to practice. In the next session, we will start doing some simple programs, and in those programs we will see how to make functions and how to pass variables and all these things. We will make use of these array things as well, and it is up to you to go back and look up the documentation and practice. There is nothing very difficult about all this. There are a lot of examples available on the internet. Okay, so I'm gonna stop this session right over here because there's less than 1 minute remaining. Okay, so I've stopped the share, but we will join back after a few minutes, right? Hello.
Yes, sir. You